everyone. Thanks for joining us. Thanks for coming in person. Thanks everyone for joining us at home. Today we have Chris Carter, one of our OG grads, talking about the skills you need after graduation. And they're going to also talk about their experience here at the Tech Academy as well. So thank you for being here and take it away.
My pleasure.
Also, everyone at home, make sure to leave your questions in the chat box and we'll get to that.
Oh, gee, it makes me feel so old, but I guess I'm kind of getting OG these days. So, well, my name is Chris Carter. It's kind of weird to be here at the Tech Academy talking about stuff I didn't learn at the Tech Academy that I'm using in the real world. But I'm glad that I have an opportunity to do that. Just a quick bit about my pedigree. So I graduated from Tech Academy in 2016. Which seems like just a couple years ago, but I guess it wasn't anymore. I went right into a cool contract at Intel through Vanderhewen, one of our local contracting companies, and that was a great experience. Spent 18 months doing that. Had a little bit of a dry spell where I did a few other things, but then my next contract was through Apex Systems at US Bank, and that was fantastic experience. In fact, the next year, in 2019, I transitioned to full-time employment at US Bank. And then most recently, starting last year, I'm at Genesis Financial Solutions, which is a credit company out of Beaverton. Here we are. So, my experience at Tech Academy was that I got excellent foundational training in the basic skills that I needed to go out and code. So, coding, obviously, version control, and software development life cycle were the three courses in my curriculum, which were really fundamental. When I got out there, I felt like I could go and write code and be a strong junior developer. But what I also learned was that a significant portion of your workday is going to be taken up with non-coding activities. Are they still teaching that little that pearl of reality? It's true. So part of this talk is, well, what are those non-coding activities you're going to have to do? And then even when you're writing code, it's different when you're writing it for enterprise versus writing it for yourself. So whether you're at a boot camp or university or just playing around at home, your own apps. So I kind of chose 5 different things that really stood out to me. One is multiple task management. When you're in the workplace, there's a lot of this going on. Developing software on a team, there's some differences there. Developing software for an enterprise is really different. Then deploying software, as I've said before, is the one thing that when you finally get a job is completely new for the most part. I mean, you've never had to deploy software before. You've just written it and run it on your local machine. And then finally maintaining production code, which also is probably completely new. So let me start by just kind of giving an idea of what a day in the life of a software engineer is like. This used to say typical day, but typical. So not every day is going to be this crazy, but I've certainly had enough days like this. So the day starts with a stand-up meeting where you get together with all your colleagues. After stand-up, you'll do code reviews. Typically, as a senior developer, especially, the devs on your team will have 2 or 3 code reviews that they've been doing that are ready for you to look at and finish the pull request. Then you get to code on your own story. As a senior developer, I was typically taking a couple stories per sprint, and I'm kind of transitioning into a lead role now, where I only do 1 story, but I'm also kind of working on every story. So you get some time here to code, and maybe you raise a PR, a pull request, to have it pulled into the main repository. And right after that happens, you take a call from one of your devs because they need a little bit of guidance. And so you kind of drop what you're doing and grab that call off Teams. Then meantime, somebody has approved your pull request, and so you can merge and deploy your code to the test environment so the testers can get onto it. But while you were coding, you realized that you did have some story requirements that weren't really clear. So you set up a meeting with the product owner to talk about those. You had a scheduled working session with your devs because you're all kind of working on the same code base, different parts of it, and you need to figure out, okay, how are you going to call my component, and how is my component going to respond to your component? What are the details of the classes? How are we going to coordinate our efforts here? Then you got some time to code again. Then this meeting that you set up with the product owner, you go ahead and meet with them for a few minutes. And you had a pre-existing meeting with your junior dev to help them work through their code. And sometimes that will go quite a long time. It's always fun to just have a chance to sit down for 90 minutes with your junior dev and just kind of go through stuff. And then you comes the one-on-one with your manager. That's actually what I did just before I left to come here. So once a week, you should have a one-on-one with your manager, typically, or at least every other week. And then the day is pretty much over, which means you get to code some more. And that's good because you just clarified your requirements with your product owner. You can finish it up. And then when it's finally time to hang it up for the day, you commit your code changes and call it a day. And depending on what kind of day that is, that can be at the end of 8 hours, or it can be because it's bedtime. So not a whole lot of those other days, fortunately. So as you can tell from that, one of the things to deal with that you don't have to deal with when you're training or just playing around for fun, managing multiple tasks. You're going to have to prioritize multiple tasks across multiple projects. Like I said, as a senior, I would typically have a couple stories that I was working on at a time. Now I've got my story, but I've also got all the other stories. Sometimes things get reprioritized or things get added. If there's a production bug that pops up, you kind of drop everything and you fix the production bug because that obviously is a kind of alert. And obviously, you're going to have to manage interruptions while you're coding. And that's hard because coding, you have to kind of get yourself in a mindset and you have to juggle a lot of different variables that you're trying to put together. Then somebody calls you or you have to go to a meeting and you have to drop all that and then you have to pick up the pieces later on. And they're really, I'm not going to teach you how to multitask. That's a complex story, but I can share a couple tools that I've developed. First is this. I learned this from one of my old bosses, Keith Ozaki. Hi, Keith. And he didn't use spiral notebooks. He had the really nice bound notebooks, but I just use spiral notebooks. And so every day, it's just you put the date at the top and you put a little highlighter across it. And then you just take notes. As things come up, if somebody shares, oh, the repo is over here, you go, okay. And that's just you're at the right hand of your desk all the time. And so you just take your notes that way. It's faster than trying to take them on the computer, at least it is for me. And the nice thing is that if you go back and say, what was that story that I was working on? What was the number of that story? Because somebody just asked me about it. You can flip back 2 weeks and find it. So I find this actually to be immensely helpful. And as I've transitioned into being a tech lead, and I have to kind of manage a team, I started printing these out each day before stand-up. So I put the date at the top. These are all my tasks that I have to do throughout the day, and I'm always adding new tasks as things pop up throughout the day. And then these are all my developers and testers. The names have been changed to protect the innocent. And what they tell me that they're working on for the day, so I can keep track of that. And then down here in the purple are all my personal tasks at the end of the day. So for example, I shall show you. So this is today's. This is my real world task list. And yeah, down here it says tech talk. So I don't forget to give a tech talk. Also paint the house is down there. So as I think of things that come up, personal things I've done after work, I put them there too. So these are the two tools that kind of keep me organized and allow me to kind of flip back and forth between tasks. So moving on to developing software in a team. I was really fortunate in my first 3 projects were all big greenfield projects, from scratch, and I did them entirely on my own. I did everything from designing the database structure to writing the backend to deciding what color the buttons were going to be on the screen. The whole thing, 30,000 lines of code, and it's all mine. And so I got to do the whole software development life cycle, from design and implementation and testing to deployment, all by myself. But when it came time to kind of read one of the projects from the ground up again, because a lot of the requirements had changed, I was paired up with one of my colleagues to do it together. And initially I thought, well, I feel like I'm giving up a lot of autonomy, because now we have to negotiate, and some of the ideas are going to be his and not mine. But I found it was really cool to work as part of a team, because he had ideas to greatly simplify some really complex problems that I had been having. And he caught things that I didn't catch. And we got to divide and conquer. And it was really great working with a colleague. Just made things a lot easier. And it helped me to grow as a developer, because I got exposed to different ways of doing things that I wouldn't have considered before. So the ideal team size is definitely more than 1. Although it's really fun to be the one and be a prima donna and do the whole thing yourself, because you learn a lot very fast that way too. I think in my experience, 5 is generally kind of the upper limit. Once you get above that, then everyone kind of starts stepping on one another's toes. You can have really big projects that are really well managed that have bigger teams. But in my mind, I think the ideal team size is somewhere between 2 and 5. One of the things that I'm increasingly, as I get to have more and more responsibility on the team, increasingly aware of is that it's super important when you're developing in a team to be able to communicate with the rest of the team. As the tech lead, I'm kind of responsible for making sure everyone's on track, making sure that we're headed towards completion at the end of the sprint. And my day looks a lot like this. So what I need to hear from all of my developers is, where are you headed over here? When are you going to turn back in towards the airport? What altitude are you flying at? So, and there's a tendency among a lot of developers to to try to kind of hide the fact that they don't really know what they're going to do today, or if I mumble enough, they realize that they won't realize that I'm not really making very much progress. But it's okay to not be making progress. That's the great thing about software development, is it's a big puzzle. I mean, we're all, I hope, kind of puzzle people, because you're faced every day with these little intellectual problems that you've got to figure out. So it's okay to be stuck. But if you can just get really good at saying, each day on stand-up, this is where I'm at after yesterday's work, and this is what I am going to be working on today, so that you have an idea of where I'm at out there in space. And if I need help, I need to get together with somebody later today to figure out how to log into this repository, because I just haven't been able to figure it out. If you can just say those things, just right up front, boom, 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 it just is so helpful. So communication is a big part of working on a team, and it's not obvious. It's not intuitive to a lot of people. Also, you have to pace yourself, because typically you're going to be doing 2-week sprints. And so you have to make sure that you're on track to finish up by, Tuesday of the second week, so that you can get it to your developers. And so you kind of need to really be regulating yourself. And some weeks, some sprints, that's great. You're just kicking back, and everything turned out to be pretty easy, and I'm listening to music, and I might even, get off an hour early today. Other times you're like, whoa, it's Thursday and I'm way behind. So this is going to be one of those days when I kind of work until bedtime and maybe a little bit over the weekend because I have a lot of work to do and the sprint is halfway over. And developing the code is only 2/3 of the sprint. Like I say, you still got to test it and then go back and debug it and deploy it. So you have to kind of have this overall awareness of where you are. It all averages out. There's some bad weeks, but there are also some nice easy weeks too. And you have to then coordinate with other team members. Like I say, I got to live the magic life where I didn't need to coordinate with everybody for the first couple projects I did. I just kind of kept it all in my own mind. Like, this is the way I'm going to do this, and this is the way I'm going to do this. But when you're working as part of a team, you need to decide, what are your coding conventions? Are your private variables going to start with underline small case? Are your constants going to be all uppercase? What are your architectural conventions? Are you going to use a repository pattern? And are you going to use dependency injection? If so, which libraries are you going to use? Are you going to do the basic .NET Core dependency injection, or are you going to use the third-party library like Ninject? What test library are you going to use? So you have to decide on all that. Then you have to divide your tasks, of course, and decide how you're going to interface. So we're working on a project right now where it's myself and then two devs on my team, and I'm consuming an API from a third party and packaging that into a response object. So they call me as an API, and I'm kind of a gateway to the third-party API. So we need to talk about, what are your request objects to me going to look like, and what are my response objects to you going to look like? Then it turns out that the third-party API changed, and so all of the objects changed. And so I had to change all of my response objects and then communicate that back to them. So there's a lot of negotiation around interfaces if you've got multiple people working on different parts of a project. How do you get those parts to fit together? And then there's the software itself. So developing software for an enterprise. If you're developing software for yourself, you probably don't really need to document it. But you sure as heck need to document it if you're developing for an enterprise, because there's going to be a lot of people who need to know how to use it, and even a lot of devs who are going to need to know how to maintain it. So you're going to need to document for both of those groups of people, and for a decade out in the future, because a lot of enterprise software has a very long lifespan. So you're probably not going to be around. So it's really important to leave a documentation trail. And then there's a whole enterprise architecture that ensures that your code is durable and testable, it's maintainable and extensible, which means that you can take it and add new pieces onto it or change it as new technologies arise. So let's start with documentation. There's not a whole lot to say about documentation, except just do it. I see some paint on me somewhere. I'm painting my house right now. And the painting job is not done until you wash all your brushes and take all the masking tape off. And your application isn't done until you've written the documentation for it too. I pride myself in having code that pretty much is easy to read. You can kind of read through it and see what's going on. But every once in a while, there are little tidbits, and I leave comments like, this seems like a weird way to do it, but I tried it the way you think you'd do it, and there's a glitch in the language that just doesn't let you do that, or whatever. So leave little comments when they're necessary, and of course the written documentation. But mostly just do it. It's not nearly as exciting as writing code, but it's just got to be done. So as far as general principles of enterprise architecture, that's a huge topic, and I highly encourage this book over here by Martin Fowler, Patterns of Enterprise Architecture. It's got everything you'd ever need to know. But I thought I'd just touch on three things: separation of concerns, encapsulation, and abstraction. And you've probably heard a lot about these things. So let's talk about separation of concerns first. You want to write your code so that it comes in little pieces, and each piece just does one thing. So this piece does one thing. In the middle, it may call another piece that does one particular thing too. And it moves on to the next piece that does one particular thing. If you have little pieces like that, then it's easy to test each little piece. And you can substitute a downstream piece in your testing framework, a mock. And so you can isolate each little part and makes it much more testable. Also, it makes it more maintainable and extensible, because if you need to fix something, ideally, your changes will be just confined to one component. For example, I like to use the repository pattern. So if something changes in the database, if the database schema changes, I know that I just have to change the repository for that item. And that catches all the changes in the database. And because it abstracts them, nothing upstream sees the database changes. So none of my domain classes has changed, just my entity classes. So isolating things like this makes them much more maintainable. And I'll show you some examples. And obviously more readable, because you can say, well, this piece of code is doing this, and this piece of code is doing this. So it's kind of like building models, right? So here's a plastic model of a motorcycle, and it's just very elegant. It all fits together perfectly in one piece. It's kind of like, code that's just written in one big monolithic chunk. And once you get it all glued together, it's permanent, and you can put it up on your shelf, and it's done. But if you were to build it out of little individual pieces, each one of which just does one thing, then it may not quite be as elegant, but the same kit will make this, and it'll make this. So if you want to change from an on-prem solution to an Azure solution up in the cloud, you can take your same pieces and just rearrange them a little bit, maybe change out one or two, and it makes it much easier to do that. Encapsulation. So, and this kind of goes along with separation of concerns. So, each bit of code that does one thing, to some extent, stands on its own. And that means that you can have controlled interaction with other bits of code. It may be other bits of your own code, or it may be code that's calling it. So you may be writing an API that somebody else's code calls in remotely to. So you want to basically protect yourself from whatever shenanigans that other code is going to try to pass you. So if you look at the incoming data, you need to validate all your incoming data, especially null checks. So because if you have a null request object and you try to reference something inside of it, it's going to throw an exception. So the first thing I always do is say, hey, if the request is null, then return a bad request, 401. And you may even want to constrain the incoming data. So instead of just using strings, you may want to use enums. For example, one of my inputs is called telephone context. Is this a mobile or a home or a work telephone? Well, I could use a string, mobile, but somebody could very easily misspell that. And if I try to compare this with with mobile, say, does it equal mobile? Well, it won't. So to avoid this sort of magic number or magic string, you can say, I don't want a string, I want a class called phone types that I have defined. And so I want you to pass me a phone types.mobile. And internally, this just basically translates to this string. But I don't have to rely on other people's code to get their spelling right? I mean, if you don't type phone types.mobile, it's going to be an error. Like there's no phone type mobile without an E. And so that's what these people are doing here. They're checking the incoming data and they're doing a null check on it. So just like those folks, you have to be really paranoid when you're encapsulating. Make sure that you are getting a good request before you even start. And then when you're providing outgoing responses, try to provide a meaningful response for each case. And sometimes that's a meaningful error message, like bad request. But a lot of times you want to have an error message along with that. One thing I've seen a lot of people do is if something goes wrong, they just return an empty object. I'm supposed to give you this object, and something went wrong, so I'm just going to give you an empty object. Well, that could be really misleading to the other person because they got an object, but it's not really an object. Really, what you wanted to do was to return null. It's like, nothing happened. I'm returning you nothing because something went wrong. So to do these things often requires you to write a response wrapper. So a lot of times in my repositories, I'll have a repository response, and that'll have, a Boolean flag, was there an error? An error message, which hopefully is null because there was no error, but if there was, then that's populated. And then you have the object that you're returning. So, and hopefully that's populated. And that way the people who are getting your response can just say, if is error, if, was error is false, then proceed. So that's really helpful. But yeah, the encapsulation is kind of key. You make a fort around your bit of code, and that way at each point you're just making sure that you are dealing with a known quantity. And the third principle I want to talk about is abstraction. How are we doing? Yeah, pretty good. So the classic pathway for abstraction is the 3-layer model. So you have your presentation layer, which is your user interface. And all it does is presents data to the user. It doesn't do any processing at all. Any information that it has to have is handed to it by the business layer. So the business layer is where all of your logic happens. And that is often actually subdivided into different layers. But any processing, any logical interactions happen in the orange layer. And then the data access layer just gets your data. So one of the features that you can do is you see that your entity classes, and by entity classes, I mean the classes that describe your database tables. So the entity class is basically a representation of your database table. Well, the access layer needs to know what those are because it needs to know what columns to look for in the database. But your business layer shouldn't know about the entity classes because you may very well in the future change from a database to the cloud, or you may change from a relational database like MySQL to a NoSQL database, which basically stores big JSON objects. And so the way that you store things in a SQL database versus a NoSQL database is going to be radically different. And so your entity classes are going to be radically different. But if you abstract your domain classes from your entity classes with an adapter, that means that anything that happens in your data layer won't affect anything up here. So I was kind of talking about this earlier. If you make a change to your database, you know that if you fix your repo, that there are no more side effects above the repo. Because the repo, the repository that is, has an adapter, and it returns domain classes. So it doesn't matter what happens to your entity classes. It's just going to affect that one component. And then likewise, obviously, if you're going to migrate to the cloud, which we're currently doing at Genesis, you just write a new data access layer. And I'll show you a little bit about that in just a second. So this is the way that you would write code for yourself. Say you have a function that just retrieves information from a database. So you have a function, it retrieves information from the database. Easy peasy. No need to make it more complex than that. But you wouldn't want to do this in an enterprise. So for an enterprise, you might choose something like this. You might have your function, and your function might call a service that is responsible for repackaging and processing the information from the database into a meaningful domain, real-world domain object. So, for example, if you want to create a family object, you may actually make multiple trips to the database and through multiple repositories. You might want to get the the parent object, and you want to get the children object, and you might want to get the house object, and then the service puts them all together into a family. So the service does a lot of the processing in the background, and this is an example where the business layer actually gets split up into two layers. So you have your function layer and your service layer. The service then calls a repository, and the repository's only function is to access the database. So and a lot of times to access a single table in the database. So if you have 10 tables in your database, you may have 10 repositories. So if you change a table, you may only have to change that one little repository. Notice that the function doesn't call the service directly. The function calls the iService. It calls the interface. So it says, I don't know necessarily what kind of service I'm going to get, but I know that whatever service I get is going to communicate with me through the iService interface. So and I'll show you the beauty of that in a second. Similarly with the repository, the service calls an iRepository, and the repository ends up being the implementation of that interface, whatever it is. So let's finish up with testability. Well, actually, let's talk about your goals for your application. Testability. So you want to have unit testing, certainly, and you might consider integration testing. Unit testing is to take each one of those little bits of code that stands on its own, single responsibility principle, and to test it in isolation. And the advantage of that is twofold. Sometimes, if it's really complicated, it can help you during the development process to see when you get it right. I wrote an application. It was either in Tech Academy or right after that took a little random landscape, and it did 3D rotations. So to do that, I needed to do 3 matrix multiplications on the data. And it took several tries to get that right. And that's one case where I did test-driven development. I wrote my unit test first so that when I got it right, I would know. Most of the time, I end up writing my unit test a little farther along because the requirements take some time to settle down. But by the end, it's really useful to have them, because when you maintain something and you change something later on, say next month, if you update a component, then you can run through your unit tests and make sure you didn't change or break anything else. Like, oh, I didn't expect that would break. But your unit test will tell you before your production deployment tells you. So testing is important. What and how much? There are a lot of opinions as to what you should test and how much you should test. Very few people want to test 100% of the code. Some code's not worth testing. A lot of people will say, don't test the underlying frameworks. You have to rely on, if you're using Entity Framework, you just have to rely on the fact that if you ask it to retrieve something, it's going to retrieve it. Microsoft is taking care of that. You need to test your code. But each company will kind of have guidelines as to what they want you to test and how much code coverage they want. There are different frameworks, and a lot of what I'm going to be saying here is very .NET centric, because I'm a .NET guy, but the same things apply to Java and other frameworks. And in fact, one of my real jobs was to apply the Jasmine test network or test framework to an application that was written entirely in JavaScript. So the whole application was JavaScript. But in the .NET world, MS Test is kind of the default test framework that's supplied by Microsoft. NUnit is the long-standing third-party alternative, and XUnit is kind of the newfangled update to NUnit. So there are different frameworks to choose from when you're testing. All right, so here's the first place where I get to show you why this ridiculously complex solution, remember, I took something really simple and elegant and I made it really complicated. So the question is why? Well, here's the first reason why. Because if you have an iService and an iRepository, you can, using the mock library, very easily mock your service. So you say, okay, I want a mock service, which is a mock of the iService interface. And so, and you can even say, and if you call this mock service in a certain way, I want it to return this. So you have a controlled test tool. And so by using the iService interface, you can decouple your function from the service. Instead, you point it to a mock service, and now you're just testing the function in isolation, and it's getting known inputs. Likewise, you can create a mock of your repository, and you can call test methods on your service, and it's going to get known responses from the mock repository. So by breaking it up like this, it makes each component more testable because you can test it more in isolation. Otherwise, you would call a function and it would go to the database and something would go wrong, and it's like, well, it could be anywhere, right? This way, at least you know, well, my function's working and my service is working. So maybe my repository is having difficulties communicating with my database. So this is where the more abstracted, a little bit more complex enterprise architecture comes in handy. Durability. You want your code not to be brittle. You don't want little problems to completely blow up and just throw an exception. Because you're writing code that has to interface with lots of different components. You may not even be aware of all the different components that it's going to be interfacing with. And it's going to be doing that for decades to come. So you need to make it really robust. So try to identify all the possible scenarios and inputs. What could go wrong? Maybe I get a null name. Well, I don't know how that would happen, but it could happen. It's possible. And so I should deal with it. What if I get a null request? I don't know how that would happen, but it does. And one of the applications I was recently working with, this would happen all the time. It would make a call, and the call would, it wouldn't fail, but it wouldn't find what it needed to find. And so it would just return a null. And so then you would take that information and you would make the next call with that information. And it wasn't the call that failed that threw the exception. It was the next call because it was getting a null input from the prior one. So now after every call, I say, okay, I make the call. If it's null, then return an error message. And if it isn't, then go ahead to the next call. So just try to be really paranoid and figure out what are all the different ways that this could go wrong. Because if it can happen, it will. Use encapsulation, validate your inputs, give consistent and rational outputs, error flags, messages, that sort of thing. Catch exceptions. So a lot of times when I'm in a function that will make repeated calls, remote calls, like to the database, I'll do a try-catch block around each call, because that's where you really can have problems, is during those remote calls. And that way, I can send a very specific error message back and say, this function failed because at this call failed. Or you go back down further and say, oh, no, this call failed. So having multiple try-catch blocks along the way will allow me to give a lot better input to my calling code if something goes wrong. But don't rely on your exceptions for logic. Don't say, well, if this is null, then just throw an exception. you want to try to avoid that as much as possible, because exceptions are time consuming and very resource consuming for the language. So you don't want to rely on exceptions for your logic. They want to be you want to catch them and deal with them and return an error state. And exceptions should be your last resort. But do make sure you have a way to catch them. Maintainability. Obviously, you need to document if people are going to be maintaining this after you've left. Logging. Lots of logging. This is one thing that really surprised me when I went out in the real world, is how much logging people do in enterprise software. Because when you're running it on your local machine, you can just debug it. Why do you need logging? But when it's running in the cloud, the only way you're going to know what happened is if you leave a good logging trail. So logging becomes really surprisingly important to maintain your code. Things will change over time. For example, I'm writing this API interface, and it's going to call the third-party API a number of times before it finally decides that I'm giving up. The third-party API must be down. But I don't put that in the code. I put that in the configuration file, because the business may decide next month that they only want to try twice. They don't want to try 3 times. Or they may want to change the timeout. So my timeout is currently set at 30 seconds. But if we decide that 99.99% of the requests are having problems, or no, are coming back within 5 seconds, then we can change the timeout to just 10 seconds. And that way we don't have to wait a whole 30 seconds to find out that their API is down, right? You'll know pretty quick. So a lot of things go into configuration files, web.config or app.config.json in the .NET world, or sometimes we just use a flat file, just kind of sitting there on the server instead of these. When we're deploying to the cloud especially, our configuration values are actually held in the cloud itself. So you go into Azure and you say, for this environment, these are the configuration values. And the advantage is, if you want to change something, you don't need to change your code and recompile it and redeploy it. You just change the value of your config, and it takes 5 minutes. So a lot of things are in configuration. That was not a technique that I used on my own personal local software, but it's really useful in an enterprise environment. And then obviously, if you want to maintain things, it's easier if it's divided into smaller assemblies, projects and libraries, or even smaller applications. You may have a service or a microservice architecture where I have a little piece that does something, and then it calls another little piece that does something else, and then it calls another little piece. It's not just one application. It's several little applications. And we tend to use that at Genesis. So there will be times when I am testing a piece of software that I'm working on, and I may have 4 different instances of Visual Studio running on my machine all at the same time, because this instance calls this instance, calls this instance, calls this instance. And so I can track the request as it goes from one application to another, comes back from the database, and then gets passed back up the chain. And it's complex to test, but it makes it very maintainable, because you just have to deal with one little bit at a time. Are we doing on time? Good. We'll skip over this. This is just an example of how we're doing this at Genesis right now. But we're kind of running short on time. Extensibility. You're going to want to do new things with your code in the future, in all likelihood. Like I said before, one of the things we're doing in Genesis is we're taking some of our on-prem stuff and we're moving it to Azure. And so we're sort of extending our functionality that way. Again, easier if you separate your concerns. You're You'll isolate your changes to one little component. You won't have changes that you have to make all over the code base. Abstraction also helps by isolating each one of those components. Whenever you have components that are transferring information to and from, one of the things that you should do, and we just implemented this in this week in the application that I'm working on, where 3 of us devs are working on the same thing and we need to talk to one another. When I updated my classes that are returned to these other applications, I put it in a different project. And then I said, don't try to write your own classes. Just take this project and import it into your solution. So I've already written it, just use the same classes. And ideally, I would publish it as a NuGet package. So they would just they would just say, import NuGet package, and it'll be something that I've written and put up on NuGet. And then all the classes that I'm sending them, poof, just magically come into their application. And if I have to update my classes, I just update it, I republish it to NuGet, and NuGet says, hey, there's an update in one of your packages. And then they get all the new classes. And we don't have 3 people trying to write the same classes by hand and hoping they all match up. So yeah, if you've got data transfer classes, just put them in one place and share them. Don't rewrite them in every application. All right, so we're getting towards the end. Extensibility. So here's where this architecture really comes into its own. So here's the core architecture we started with. We talked about the fact that by coding to interfaces and breaking these into separate parts, we could make test mocks that allow us to test these things more easily. Well, your service is doing a lot of data manipulation. And what if there's another function that you want to write that needs pretty much the same data manipulation? Well, you just point that function at your same service, and you don't have to rewrite it. So you just say, this function had an iService injected into it when it was created, and go ahead and inject that same iService in the function too. And that way I can reuse this code. So code reuse is one huge advantage. Say there's somebody else's app, entirely different application, but it needs to access a lot of the same information that you do out of your database. Well, actually, before we even get to that, notice what I did. These are all grayed out now because we're not on-prem anymore. We've gone to Azure. So I replaced my database repository with an Azure repository. But because they both get the same information, they're both returning the same domain classes, they both have the same interface. They both have the same protocols. And so the service can call this repository using the same calls that it used to call this repository because it has the same interface. So you just say, yeah, don't give me one of these. Give me one of these instead. And now all of a sudden, you're getting your data out of Azure. In fact, you can swap back and forth. In your configuration file, you just say, give me one of these. When I ask for an iRepository, give me a database repository. Or no, when I ask for an iRepository, give me an Azure repository. And in fact, I do that in my application. I have an isTest flag in my configuration. And if isTest is set to true, then it goes to a test repository. So you can, by having the same interface, you can swap back and forth. And now you've just extended into the cloud. Another application, if it needs to get the same information, can basically just call the same repository. All right, deploying, and we'll have to finish up real quick here. Deploying strategies. Again, there's not much I can say in this about deployment, but it's a whole new thing that you don't do for the most part when you're writing your own applications. There's blue-green deployment, where you just basically have 2 sets of infrastructure and you swap one to the other. There's rolling deployment, where you basically do it one server at a time. And so you can see the problems grow if your new deployment has a problem in it. And there's canary deployment, where you have two different sets, just like this. But what you do is you take certain users, your canaries, who are experienced users, and you move them to the new application first, and they will tell you if there's a problem. Meanwhile, the vast majority of your users are still in the old safe version. But yeah, there's a lot of ways to deploy. One thing that I always say is get your own account on Azure or AWS or GoDaddy, or something remote where it's remotely hosted, and practice deploying. Write it on your machine and deploy it up in the cloud. I mean, GoDaddy is basically up in the cloud. It's being hosted not on your machine, and just get a feel for, how do you deploy stuff remotely, and then how do you monitor it afterwards? If it's in Windows, learn how to monitor IIS, which is the application that actually serves web pages in Windows. If it's in Linux, which is to say Nginx or Apache engines, there are third-party tools. And if you're in the cloud, like Azure, there's part of Azure called Application Insights that will tell you if errors are happening, how many calls, how long they're taking. And then this, I think, is this is the last slide, I promise, because I think we're there. Maintaining production code. So here you are, and I'm working for a financial services company. So, millions of dollars are flowing through this every day, maybe every hour, I don't know. But you don't want to mess it up. It's a lot like open heart surgery, right? You have to operate on this heart, and it's still beating, and you can't just stop it. It has to keep beating while you're operating on it. So when you're making changes to production code, which you have to do, you just have to be really aware of any other dependencies. Are there database tables that need to change? Are there other applications that are using the database tables that you're trying to modify? Are there other applications that are calling your application, and you're going to break them because you're returning information in a different way? Are there unintended consequences? Oh, I didn't know that if well, here's an example. We return error messages to our retailers if something goes wrong. Well, if we change the error message just a little bit, their systems may not recognize it anymore. So, I think it came down to commas at some point, that we had to remove commas because it wasn't matching with their systems that we're expecting. So that brings me, I'll jump ahead to this and then back up. One of the things I'm really bad at, when I'm taking code that's in production and I'm making a change to it, I want to fix all the other little things that are wrong. Like, look at all these typos, right? Can I fix the typos? Can I kind of rearrange things to make more sense? And I'm constantly getting my hand slapped because no, you don't want to do that. You want to change as little as possible because you never know when some little thing like adding a comma is going to break something else that you didn't anticipate. So change as little as you possibly can to get your desired result. And what that means is that over time, you're going to accumulate tech debt. You're going to accumulate all these little things where you're like, we shouldn't have done it that way. But we can't change it now because it's in production and it ain't broke. So don't fix it because you might break it. And how to deal with tech debt in enterprise production systems is a whole nother topic, which would actually be a pretty good topic for Tech Talk. But it happens. Just like DNA errors as you get older, you just get tech debt in applications. But one of the hard lessons for me was don't try to fix it. Once it's in production, just don't try to fix it. Do as little as possible. You really have to be careful to manage your repository branches. So make sure that all the changes and only the changes that you want are going to go into your release branch. Make sure the release branch gets merged back into master after you deploy it, and then make sure that your development branches get refreshed from master. So you really need to know what's going on with your code base. We have change control meetings before each production deployment so that everybody knows what's getting changed, and there are no surprises. It's the last chance for somebody to say, hey, you know, that's not completely tested. Let's put it off to next week. And deployment. Make sure you're deploying the right code to the right servers, and then do smoke tests right afterwards. Many is the time that we've said, something's not working. We've seen errors coming through now, and we roll it back. And if we can figure it out right away, we do, and we redeploy. And sometimes we say, well, let's figure it out in the morning, and maybe redeploy tomorrow. So, you know, all three of these things need to be done very carefully when you're working with production code. To some extent, automated regression testing, unit tests, can be really useful. If you change something in your code and there's an unintended consequence, if you rerun all your unit tests before you redeploy, it might catch one of those unintended consequences in some other part of the application. It's not going to obviously look at other people's code, though. So if they're calling your code and you broke their responses, then it won't catch that. But regression testing can be a useful way to save yourself a little bit of heartache when you're maintaining your production code. So that was a pretty quick trip through, you know, what's a little bit different when you get out there and start working for a company versus what do you do at home and what do you do in the environment. But hopefully it gives you a little bit of a flavor. And so I'm excited for all you to get out there and be working surrounded by other devs out in the company and writing some exciting code that makes the world go around. So, and I've left probably like 1 minute per message for questions. Oh, no, it's exactly 2. But anyway, any questions?
Is there any questions?
Yeah, Chris, where are you in the picture?
I'm actually in the camper.
I understand.
Yeah.
How much experience with this did you have?
My deep dark past. So I was actually kind of an early adopter. I got an Atari 800 in '83, and I wrote some stuff in BASIC, but I never got very skilled. I mean, it was all basic stuff. Never did anything. I was never a whiz kid. But you know, since I guess I was junior high, since junior high, you know, I've had exposure to home computing. In college, Lewis and Clark College, good place. I was a research assistant, and I did numerical modeling in Fortran on a mainframe. We were looking at solar observations and trying to figure out how water vapor was interfering with them. So I did that for 3 years. And then in my previous life, I did dabble a little bit. I directed an ICU for a while, and we needed to keep track of our patient base and our outcomes. So I wrote a little Microsoft Access database and a little reporting module, but nothing professional until I got here.
And how much time did they do with like in the program? How much of it was dedicated to setting up to secure?
Oh, it was great. It was great. So I really burned through my time at Tech Academy. I think I started in March and graduated in June, something like that. 11 weeks, I think. So it was 10-hour days pretty consistently. Just boom, 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 boom. Got through pretty quick. 2 crucial things happened. They have the job placement module, or they had the job placement module when I was here. And I just basically followed all the recommendations. I've been writing resumes for a long time, but I really liked the resume model that they had there. And so I adapted my resume to look like that. And it was like, wow, that's so much better, so much better. So I basically just followed the directions in the job placement module, and I did the live project and did some really cool stuff during my live project. Stuff that when I went and interviewed, I could talk about, like, I've done, yeah, I know Agile, I've done sprints, I implemented this, so I could say, yeah, I've had real world experience in a real production website, and I've implemented new functions. I've maintained old functions. I've deployed. We did a database migration, and so I could talk as if I had done a lot of real world experience, because the job placement live project was in fact real world experience. It was a real live website, and I did real meaningful work on it. So those were the two things that were crucial that I got out of Tech Academy.
We still have the extended job placement 3 months after graduation. This is part of our job placement team here. And then we have blood drops, and it really benefits the students when they graduate.
Yeah.
And do you have any more questions?
Yeah, it was like magic.
Well, you worked hard and you did really well, so that was awesome.
Yeah, you have to work hard. You do have to work hard.
And your previous life was healthcare.
Yeah, so I'm used to long hours.
Okay, we have some questions from people online. You might have to repeat this. I don't know if they can actually hear me ask the question. So Sherry's asking, will you define the concept of on-prem?
Oh, good question. So I've been throwing around these concepts, on-prem. So on-prem is on-premises. So that is what you would classically think of. You are a company, and somewhere in your basement you've got servers, and your databases are held on those servers, and your websites are served from those servers. So it's all on-premises. The alternative to on-prem is in the cloud, where you don't have the servers. Microsoft has the servers, and you just say, hey, I want you. You can actually rent servers, but most of the time you just say, hey, here's an application, and I want you to host it on a server. I don't care, they're your servers. I just want to be able to log into it and have it served from somewhere. I don't want to maintain the server. I don't want to patch the server. I don't want to have a security guard around the server. That's all your problem. I just want to put my software on the server. Right. I just maintain the application. And one of the things I did, and this, once again, was one of the required steps in the job placement course at Tech Academy, is I wrote a little website, and I deployed it to my GoDaddy account, which, like I say, technically is in the cloud. And yes, you should all do something like that. So get used to deploying and managing things not on-prem, not on your own computer, but in the cloud. So that's on-prem. On-premises means that that the hardware that's running your system is actually in your building.
So transition going to Genesis.
Oh, it's great. I mean, they had largely done it before I got there, and it's really nice. It's really nice. In fact, we're moving more applications into the cloud, and it just takes away, one more layer of complexity. So yeah, we're enjoying it.
There's another term, iService.
iService. Okay, so, and this goes back to the old C days. An interface basically says, these are the methods that are supported, and this is the signature for those methods. This is what you use to call the method, and this is what you can expect as a return from that method. So basically, if you look at the interface for a class versus the class itself, it's the same thing, but the interface doesn't have any of the code in it. It just has the method names. So it basically is a guarantee that says whatever class implements, which is another term, whatever class implements this interface, which is to say conforms to this interface, it might have some additional stuff, but it's guaranteed at least to have all of the methods that are listed in the interface. And you're going to be able to call those methods by using the request objects that the interface describes, and you're going to get back the response objects that the interface describes. So you could have two completely different classes, for example, a cat class and a dog class, but as long as they both implement the I animal, the I stands for interface, it's basically just the naming convention in .NET. So an interface starts with I. So if they implement the I animal interface, they are guaranteed to make noise, right? Any animal makes noise. So if you call dog.make noise, it's going to bark. If you call cat.make noise, it's going to meow. But they are animals, and so the animal interface contains things like move and make noise, and so it just describes all the things you can call on the actual class.
And the next question, in your description of the workday, you mentioned agile terms like sprints, stories, and product owners. In your experience, what are the biggest differences in agile practices?
Well, my experience is not super extensive. So I've been at 3 different companies since Tech Academy. In my experience, they're actually all the same. There are many different ways you can do Agile. You can do Scrum, which basically means that you have a 2-week, you have a sprint for a certain period of time, and you divide up the work and tell people, okay, this is your work for the sprint, now go. You can have Kanban, where people are, and this is actually the way we did it at Prosper IT, where when you're done, then you pull a new task off the board and you start working on that. And then when you're done with that, you pull a new task. You're not locked into these 2-week sprints. But all 3 of the companies that I worked for do Scrum, and all of the sprints have just happened to be 2 weeks. So, and we all start the day with a stand-up, and we all have a retrospective at the end of the sprint, usually about a week afterwards. In my experience, people tend to all kind of do it the same. 2-week sprints in a Scrum framework.
And then I think our last question, will you explain smoke test?
Another. I'm sorry, the lingo just comes out. Smoke test, yeah. So a smoke test is basically a very quick and dirty test to see, is it working? It's not a detailed test where you would give it different inputs and make sure it handles each different kind of input the same. You're not completely exercising the function. You just want to basically say, did the function deploy and is it working? So basically you're just pinging the function and it says, yeah, I'm here. And you say, okay, that's a smoke test. So it's just a very coarse way of determining that it's functioning. So whenever you deploy something, you just want to make sure that it's up and alive afterwards.
Yeah, I thought of a couple. One, terminology. You're obviously coming from industry versus the school setting.
Yeah.
Class setting. Talk about story. And I guess that's an assignment of some type, but it seems like even though you've only been at 3 companies, it seems like that's been consistent through every job you've had. So what do those entail? Is that something that is fairly common through industry? You know, how those are broken up, such or?
Yeah. So like I said, each one of the places I've been has used Scrum, and Story is part of Scrum. It's actually part of Kanban too. But basically, it's not a requirement. Requirements are more granular. But it's something that they want to do, right? So it usually it's supposed to be phrased like a story, like as an account manager, I would like the tools application to allow me to suspend an account. So that's the story. And then as a developer, you would be assigned that story for the sprint. And so you would go ahead and implement a suspend account function in the account tool.
Number two is, I know when I can comment, notate your code. I've heard two versions, and let me know if I'm interpreting this right, that either one is really hard or fast, but it's more of a transition as you go along and gain experience, kind of work your way, wean yourself away from very verbose, specific commenting throughout the code.
I don't
Where
think
the
so.
code speaks for itself.
Yeah. To some extent. I mean, like I said, I think that my code's always been pretty good at self-documenting. It's always been pretty obvious what's going on. But you get better at choosing variable names that are descriptive and are unambiguous. No, that takes me back to my old days of basic programming, though. Yeah. You do in JavaScript, because JavaScript is transmitted to the remote device. And so if you have a variable name this long, all of those characters have to be transmitted over the internet. But if you write in a compiled language like C, that big long variable name actually in the background gets compiled to A. So there's no reason not to use a big old long descriptive variable name. I mean, there are limits, obviously. But no, so to some extent what you're saying is correct. As I get better at choosing good variable names and function names that are really unambiguous and descriptive, I find that I can put fewer comments in. But a lot of times my comments are things like, use this class, or I did this because, of a reason that wouldn't be obvious.
More helpful for the developer.
Yeah, and just comment and just describing some kind of weird things. So I don't know that the number of comments that I've used has changed dramatically, but I've always been pretty sparse in my use of comments. I would much rather have my code tell the story, but I still use comments. Actually, maybe that's not true. Like if I have a long function, I'll say, do this. Now we're going to do this. Now we're going to do this. And that way it's really easy when you're scrolling through to say, okay, that's the part of the process that that we're at. Some people would say if you're having to do that, single responsibility principle says you should take those and make them separate bits of code. So if you have something that's long enough where you have to comment, this, I'm going to do this, now I'm going to do this, now I'm going to do this, you should break those out. Yeah, you should break those out into little separate functions, yeah, and call them. But that's kind of one of my quirks. I like longer pieces of code.
Oh, actually, sorry. Can you use
Or just
Kanban. See, even explaining lingo. Now we got more lingo. So Kanban is another flavor of Agile. So it comes from the I have to go to my old instructor here. Comes from the Toyota production method, where they had a Kanban board, I think, right?
I've seen it and I've kind of read about it, but I haven't, we've never used it, so. But I know it's real similar.
Yeah. So in a sprint, the difference basically is in a sprint, you will assign each developer their story or stories for the 2 weeks. And that's what you have to do. And you take life in 2-week blocks. In Kanban, it's more of a continuous process where you're continuously developing. And as each developer finishes their story, they'll pull the next prioritized story off the board and start working on that.
So DFE take it up.
Right, right. But like I say, in my experience, places overwhelmingly choose Scrum. For one thing, Scrum lends itself more easily to a controlled process of deployment to production. As you say, we have these 3 stories, and they all kind of have to interact. We have to change the database structure, and then we have to change the application that's consuming it, and those things all have to happen together. And so we'll do that during these 2 weeks, and then we'll deploy it. And then we get to start fresh. So I think it just makes deployment more controlled to use Scrum with 2-week sprints rather than a continuous process where you're pulling new stories off the Kanban board.
That's all. That was all the questions we had from students online and I guess everyone here. But yeah, thank you so much, Chris. Really appreciate it.
My pleasure. Like I said, it's always nice to come back to Tech Academy. I got a lot out of Tech Academy, and it's launched me on a really fun career. So I love to give back.
Great presentation, thank you.
Thanks.